Hello students, good evening all. So welcome back to our next session. So as I mentioned in our today's session, we are going to start a new topic. So we are going to start with the 3D geometry. So we have already finished with our straight lines part in our previous session. And now let's start with this 3D geometry. So basically 3D geometry will be a typical continuation part which we'll be having in your 12th standard again. So here in this particular, so in our 11th standard, we'll be having a very basic part of it, like the typical introduction and one or two concepts, that's it. And that will be continuing the rest of the topics related to 3D geometry will be continuing in our 12th standard because relatively we'll be doing with the vector algebra also in our 12th standard. So that's why those two topics will be correlated to each other. So they are linked to each other. So in your 12th standard, you will be continuing the rest of the topics of 3D geometry along with the vector algebra. So as per our today's topic, it will be very small. So we can quickly finish it and we can do questions related to that. So quickly, I'll just give you the introduction to the topics, like what are the topics that's involving in our 11th standard of 3D geometry, because most of the 3D geometry, like the typical concepts, will be covered in your 12th standard only. So in your 3D geometry, it's a quick introduction to you, like a quick what we can say, a foundation we can say for our 3D geometry that you are going to learn in our today's session of 3D geometry. So as usual, we'll just start with the quick introduction to it, like typically what's the difference between our typical 2D and 3D, how we actually represent it, and coordinates related to that. Right, so we'll just have a quick introduction to our 3D geometry, like a 3D plane, and then we are going to discuss this coordinates of a point. So if you guys remember, in a coordinate axis in a 2D plane, if you talk about, so if there is a point, how we'll be writing the coordinates of it? X comma y. Right, so whereas here there will be a difference when coming into our 3D geometry part of it. So that's why here in detail we'll just have a look over it, how we'll be writing the coordinates of a point in a 3D geometry here. Right. And apart from that, the next concept that we are going to have a look here is signs of a point in an octant. Right. So here, okay, let me keep it in this way. So if we have our coordinate axis in 2D, right? So which means we'll be having x-axis as well as y-axis. So there, how many quadrants you guys will be having? How many quadrants there will be? 4. And accordingly, you know what are the signs. Right. So when coming to our 3D part, 3D geometry part, so here we'll be calling that to be octant. Right. So how we have in our 2D, how we have the signs of the point, like first quadrant, both the axes will be positive. Right. So likewise here in our 3D geometry for octants here, we'll be having signs of the points. So those signs also we are going to take a look here. That is signs of a point in an octant. So basically octant is nothing but in your 2D we going to call that to be an quadrant, whereas in 3D, when it comes to 3D, we are going to call it to be an octant. Right guys? And as I mentioned, in 3D part, there will be very few concepts. So the first one here is distance formula. So if you remember in our straight lines just before our session, so in our previous chapter, we have discussed the distance formula and we have applied this distance formula in a numerous number of questions. Right. So the same thing will be coming into picture here. Even in the 3D geometry, we are going to use the distance formula. Right. Then what will be a difference between the distance formula which we have seen in our straight lines and the distance formula that we are going to see in our 3D geometry? Can anyone tell me what is the difference? What are you actually expecting? Anyone? Okay, so we'll just discuss the difference and that when we are discussing this concept of distance formula. And coming to the last concept in our 3D geometry, like in our 11th standard, as I mentioned, it will be again continuing in our 12th standard, but as of our today's session in our 3D, in your 11th standard, the section formula will be the last concept. Again, section formula, it's not nothing, it's not a new topic, it's not a new concept here again, because we have already seen this section formula in our previous session, straight lines. We have even derived for both internal as well as the external division also. Right. So we have derived this section formula in our previous session itself. So it's the same thing, but there will be a small difference here. So that we are going to have a look here. So basically in your 11th standards, there is no typical nothing, like we can say there is nothing new you are going to learn here. There will be a small difference when it comes to the straight lines and your 3D geometry here. So the rest and the most important part of 3D geometry that we are going to cover in your 12th standard. So as I mentioned, it's a typical base, a foundation to your 12th standard 3D geometry. Right. So these are the concepts. So first we'll just have a quick introduction, and then we'll see the coordinates as well as the signs of the point, and then we'll jump into the distance as well as the section formula here. Right. And with respect to this, we are going to solve questions. Right. So how can we expect questions, different types of questions related to this distance formula and section formula? So here in this session, as there are no much topics here, so I have added lots of questions. So different types of questions, how can we expect questions related to a distance formula as well as a section formula in different ways. So that's all is there in our 3D geometry in 11th standard. Right. So let's start our today's session, guys. So if you guys have any questions, any doubts in the meanwhile, you can please write it down in the comment section. I'll try to reply you as soon as possible. Right. So let's start the session. Even if you feel I'm going a bit faster, you can let me know in the comment section. I'll just maintain the speed. Right. Okay. So first, we'll just have a quick introduction here. It's a 3D geometry. Right. So first, let us take a point P in the space. So here in this figure, you can identify. So in our 2D geometry, we used to have only two axes. One is x-axis and the other is y-axis. Whereas when it comes to a 3D geometry, we'll be having one more axis, which is the z-axis. Which means we are going to have three axes in our 3D geometry: x-axis, y-axis and z-axis. Right? So here you can see, you can identify a point P in this space. Right? So if a perpendicular from that point is dropped, so here you can see, so this is our x-axis, this is the y-axis and this is the z-axis according to the 3D plane here. Right. So here we have taken the point P in this space, and if we drop a perpendicular, so this will be going to fall in the xy plane. So here you can see. Right. So it's going to drop to the xy plane. Then the algebraic length of this perpendicular is nothing but considered to be the z coordinate. Right. That means here in 3D, if you identify, so if you drop a perpendicular, so this part will be the z. We know this will be x and this will be y. Right. So when you imagine, you will be understanding the coordinates here. Right. So the most important thing and the difference when coming to our 2D and 3D, there will be a new axis here, which is a z-axis, and the coordinate related to that will be a z coordinate here. Right. Similarly, from the foot of the perpendicular, drop a perpendicular to x and y-axis, and the algebraic lengths of the perpendiculars are considered as y and x coordinates respectively. Again here, this will be the x and this will be the y. Right. So the only thing you have to identify here is in our 3D geometry, you are going to have 3 coordinates. So initially what we used to write the coordinates of a point in a 2D geometry or a coordinate axis. It's simply x1 comma y1 because it's a 2D plane. Whereas here when it comes to a 3D, as I mentioned, there will be a new coordinate arranged here, which is a z. Then we'll be locating it with respect to all these 3 coordinates, which is given to be x1 comma y1 comma z1, that you can identify here. Right, that you can say like length, breadth and height in other words, because you can assume it to be a cube or a cuboid. So there, if you take it to be a cuboid, right, the cuboid will be having a length, breadth as well as the height, which is a 3D figure, which will be having a 3-dimensional there, right? So likewise, you can visualize in order to observe and get the idea of this 3D geometry here, right? So the most important thing is the writing the coordinates of a point P. So we have seen that. So let's have a quick idea here. So writing the coordinates of a point in the given space. Right. So here we will be having 3 axes, x-axis, y-axis and z-axis. So let's take a point P in the space, and if we drop a perpendicular, so this will be going to drop in the xy plane. Right, so here they have changed the axis. So accordingly, here we have taken this is x-axis, this is y-axis and this is z. Right, and then if I drop a perpendicular, this will be falling in which plane? So this area, this entire area is nothing but my xy plane. So this one is my zy plane and this one is my xz plane. Right, so if I drop my perpendicular here, what is this? So this length will be my z coordinate. Right. So when I drop a perpendicular PM, here you can see in this figure on the xy plane. So this is the xy plane. Right. And this foot of the perpendicular is nothing but at point M. Right. So then this length PM, this perpendicular is nothing but the z coordinate. And if we again drop a perpendicular from this point M to the x-axis, right, which is the perpendicular ML here. Right. So then this is nothing but the y. Right. So meeting at point L, that means here one more joining. So this is the origin here. This is the point in the space. And if we drop a perpendicular, it will be falling in the xy plane at a point M. Again, if we are dropping a perpendicular, it will be meeting the x at point L. Right. So then OL be the x coordinate and ML be the y coordinate and PM be the z coordinate. Because here the axis which we have taken here will be, so this is the x coordinate, x axis, this is the y axis, this is the z axis. Right. So if in some figures you might take this is x, this is y and this is z. So then this will be your x and this will be your y and this will be your z. Right. So accordingly, whatever it will be, according to the planes which you are having, you can correspondingly write the coordinates of the point which is taken in the space. Right. So here for this point P which we have taken in this 3D plane, the coordinates are represented by this 3 distances, which is x, y and z. So this is the x distance and this is y and this is z. Right. So then the coordinates of this point P in the space can be represented as x comma y comma z. So likewise, we can write coordinates to any of the point which is taken in the space. It's like the same how we do in our 2D plane. So if there is a point, we'll be writing as x comma y. So the same with here. We are having 3 axes. So it will be x comma y comma z. So that is how we'll be writing the coordinates of a point in the given space. Right guys. So far if you have any doubts, you can please let me know. If not, we can move ahead with our next one, that is related to our quadrants in 2D, but here it will be octant. So quickly guys, you have any queries in this writing the coordinates of a point? You can please quickly let me know. Okay, I hope no doubts so far. So I hope you guys might have understood how to write the coordinates of a point in a 3D space. Here we are all talking about 3D, right? So now let's see the octants, which are nothing but quadrants, right? So here in our 2D, we will be having 4 quadrants, whereas in 3D, we are going to have 8 octants, because here we are having 3 axes, X, Y and Z. Right. So we can take how we'll be writing the coordinates. Point P, X, comma, Y, comma, Z. So first quadrant, always, that means here first octant. Right. So all the octant signs here I have represented in this tabular form. Right. So first octant will be all 3 axes. That means all coordinates will be positive. Right. That means X, comma, Y, comma, Z. When it comes to second, X will be negative, remaining 2 will be positive. Right. So you can remember it's easily. Right. So second quadrant, that means octant. Second octant will be minus X, Y and Z. And third octant, even Y will be negative. So minus X, minus Y and Z. So you can see the sign here. For first octant, plus, plus and plus. Second octant, X will be minus, plus and plus. For third, these 2 will be minus and then plus here. Right. For fourth octant, the mid one will be minus and these 2 will be plus. Right. So for fifth one, this one will be minus. Remaining 2 will be plus. So it's just that when you start looking into in detail, you just it's like it will be a habit to you, so that you will understand how the signs of the octants are given here. Right. So in the beginning, it will be a bit difficult to remember these things. But likewise, if you are going through it, you will be able to do them easily. Right. So for fifth octant, X and Y will be positive, whereas Z coordinate will be negative. And for sixth coordinate, so you can remember all 3 plus and then minus here. For third, first 2 will be minus, that means X and Y will be negative. And coming to fourth, only Y will be negative. And after fifth, only Z will be negative. Right. And then we are having 6, 7, 8, where 6, in sixth octant, we are going to have Y positive and the remaining 2 are negative. That means X and Z will be negative. And seventh will be important, where all the 3 octants, all the 3 coordinates will be negative in the seventh octant. Right. And for eighth, only X will be positive. Remaining 2 coordinates will be negative. So keep a keen look over these octants and signs of these coordinates of in each of these 8 octants. Right, because you might expect in some mains level, you might expect they'll be giving some other question, and at the end you will be having the answer in terms of a point, in terms of coordinate. Instead of asking the coordinates, they might ask you which octant that coordinate lies. Right. So if your answer is 2, -5 and 1, in options, they won't directly give you these coordinates. Instead of that, they are going to ask you in which octant the point will lies. Right. So then which octant it will be lying? It will be lying in fourth octant. So in order to get that, you should be aware of all these signs of the coordinates in each of these 8 octants here. Right. So this is the quick introduction to our 3D geometry, like how to write the coordinates of a point and the signs of the coordinates in each of the 8 octants here. Right. So here it's a quick question. Quickly read it and let me know the answer. It's just a 1-minute question. Even you can finish within seconds. Quickly guys, tell me what's the answer here. So find the octant in which the points -3, 1, 2 and -3, 1, -2 lies. So there are 2 coordinates given here and you have to just identify the octant in which this point lies. Just now we have seen, get back to the tabular form which we have seen just now and let me know the octant of each of the points. Quickly guys. It hardly takes 1 minute to answer this. Quickly guys. Ridhishri. Who else are there? Sir, you. So here you can see what are the signs. Minus, plus and plus here. And this point minus, plus and minus. So let's get back to here and see. Minus, plus and plus will be which octant? It will be second octant. And the next sign here will be minus, plus and minus. So minus, plus and minus, which is the sixth octant here. That means the second point lies in sixth octant here. So it's just as simple as that. It hardly takes 30 seconds to answer this if we are aware of those signs of the coordinates in each of the 8 octants. Right guys, so let's move ahead with our next one, which is a distance formula. So you guys are familiar with this distance formula in your straight lines. We have learned in our previous session. It's like in our previous chapter itself. So if you are having a point x1 comma y1 and q x2 comma y2, how to find the distance between these two? PQ will be given by x1 minus x2 whole square plus y1 minus y2 whole square under root. So the same formula will be applicable even in a 3D geometry in order to find the distance between any given points. Right. So, but the only difference here is we will be having one more coordinate, new coordinate, which is the z. So, this formula will be turning out to be in 3 coordinates, which is given by x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square under root. So it's as simple as that. So you have already familiar with this distance formula in 2D. So it's just that one more coordinate will be added here. So this will be giving us the distance between any 2 points in the 3D geometry here. Right. So there is nothing new, only one new coordinate added. You have learned the distance formula, how to find everything in your straight lines. Right. So let's start doing questions related to this distance formula. So here comes the first one, guys. Quickly find the distance between given two points P and Q and let me know the answer. Quickly. So here you have to find the distance between the given 2 points. One is P with the coordinates 1, minus 3, 4, P, and the other point Q with coordinates minus 4, 1, 2. So quickly find the distance, guys. Use the formula which we have seen just now. So I'm even writing the formula here. X1 minus X2 whole square plus Y1 minus Y2 whole square plus Z1 minus Z2 whole square under square root. So this will be the distance formula. Come on, guys. I'm looking forward to your answer. Quickly let me know the answer here. So here, according to the given question, P you can take to be x1, y1, z1. You can relate accordingly, and Q to be x2, y2, z2, and accordingly substitute the values in the formula and find the distance between the given 2 points P and Q. So far, no one has given the answer. Quickly do it, guys. Quickly solve it and let me know the answer. If you guys require more time, you can please let me know that also, so that I'll just give you a few more minutes to work it on. Okay, root 7. Saryu has given some answer. Root 77. Okay, let's see. So what about others, guys? I'll just solve it here. X1 will be 1. So 1 minus of x2, so minus 4. So it will be plus 4 whole square plus, so it's nothing but PQ here. And then y1 is minus 3. So minus 3 minus 1 whole square plus z1 here is 4. So 4 minus z2 is 2 whole square under root. So here 1 plus 4 will be 5 square. And then here minus 3 minus 1 will be minus 4 whole square plus 4 minus 2 will be 2 whole square under square root. So 5 square will be 25. And minus 4, it's a square, so it will be plus. So 16 plus 4 here. So it will be 10, 15, 2, 3, 4. So root 45. So Saryu, can you just check the calculation? I hope there might be a calculation error. So here I am getting the answer distance to be 45. So that can be written as 5 into 9, 45, which can be written as 3 root 5. That means the distance between these 2 points PQ is given to be 3 root 5 units. So please check it, guys. There might be a calculation error. And if anyone got the same answer, you can let me know. Okay, fine. There might be a calculation error. No issues. Okay. You can check it later. So this is how we'll just apply the distance formula that we have seen. So for this question, 3 root 5 units is the correct answer. So let's do the next question. Let's move on to the next one. So here they have given 3 points, point A, point B and point C are the vertices of a right angle triangle. So they are asking you the question that are the given points A, B and C the vertices of a right angle triangle or not. So you have to verify whether these coordinates, these points, vertices are the right angle triangle. Are they forming a right angle triangle or not? So quickly verify that. So how can you verify? Simply by the application of the distance formula again. Okay, no issues, Haryu. So that's the it's the easiest one, but when we do the calculation, we might miss the plus minus. So that's where we have to just pay more attention. So just try to solve this one and see how you guys do it. And you can just test yourself where you are actually facing a difficulty, like where you are actually doing the typical calculation mistake and all. So quickly do this part, guys, and let me know the answer. Whether these points forming a right angle triangle or not. So that's what you have to verify. So you should be knowing the conditions of a right angle triangle first. So in a right angle triangle, it should be following the hypotenuse theorem. So first, in order to apply the hypotenuse theorem, you just find the distances of each of the side of this triangle with the vertices ABC. So for suppose I am just taking ABC here. I am not sure whether AC is the hypotenuse or not, but just I have just taken the triangle to be ABC. And now you can find the distance of these sides AB, BC as well as AC using the distance formula. And then we can verify whether they are forming a right angle triangle, which means the hypotenuse theorem or not. We can verify that. So please check the calculation one or two times, because when we are doing questions related to distance formula, the major mistake we'll do is while applying the formula, we know that it's very easy, so we'll just overlook and we'll just do some calculation error and all. So that's why you have to pay attention while just doing the calculation part here. See, what is the condition for right angle triangle? It's nothing but our hypotenuse theorem. So I guess you got it. So just it's related to hypotenuse theorem. So that's where we apply the distance formula here. So that's what I'm just giving you the idea how can we expect, like what types of questions we can expect related to this distance formula? So one can be direct question to find the distance, or you can see this question like whether it forms a right angle triangle. In some cases they might ask whether it's forming an equilateral triangle or isosceles triangle, right? So something like that can also be asked. So let's first find the distance AB. So 3 minus 10 whole square plus 6 minus 20 whole square, and then 9 minus 30 whole square under square root. And then 3 minus 10 will be minus 7 whole square here. And then here it will be minus 14 whole square. And then here minus 21 whole square. So we just have to find the squares of that. So 49 plus 114 square 196, and then 21 square 441 under root. So let's just find the value. So 9, 15, 16, so it will be 6, 5, it will be 8, and then 58, 5, 5 plus 1, 6, 686. So under root. So now we are having AB is equal to square root of 686. Similarly, let's figure out the distance of BC as well as AC. So BC 10 minus 25 whole square plus 20 minus of minus, so it will be plus 41 whole square plus 30 minus 5 whole square under square root. Right. So now I'll just write it down here. So 10 minus 25 will be minus 15. So minus 15 whole square. And here 20 plus 41, so 161 whole square. And then 30 minus 5, it will be 25 whole square. So again square, so 15 square will be 225. And then 61 square will be 3721, and 25 square will be 625. So let's find the value. So sum here 5, 10, 11, 2, 4, 5, 7, and then 7, 13, 15, 3 plus 1, 4. So it will be equal to root over 4571. Right, so let's figure out the last distance, which is AC. So 3 minus 25 whole square plus 6 minus of minus, so plus 61 whole square plus 9 minus 5 whole square under square root. So again here 22 minus 22 whole square plus 47 whole square plus 4 whole square. So 22 whole square will be 484. 47, 9, 0, 22. And 4 square 16. So finally the distance AC here will be equal to square root of 9, 6, 4. So it will be 2709. So now we have figured out all the three distances AB, BC and AC. So let's write down that first. So let me see if anyone has already given the answer. Okay, no one it. So let's write the distances here. So AB is equal to square root of 686. BC is equal to square root of 4571, and AC is equal to square root of 2709. So according to a right angle triangle, which means according to hypotenuse theorem, it should be AB square plus, okay, BC is highest, right? So we can make AB square plus AC square should be equal to BC square. Right, that must be the formulation of hypotenuse theorem. That means the triangle should be, if it's an triangle, right angle triangle, then it will be BC. So ABC. So this must be the triangle. So let's verify whether it's giving AB square plus AC square is equal to BC square or not. So AB square 686, AC square 4571. So AB square plus AC square here is equal to, so 686 plus 4571. So it will be equal to 6 plus 1, 7, 15, 12. So 4 plus 5. So it is equal to 5257. Whereas BC square is equal to 4571. That means AB square plus AC square is not equal to BC square. Which means the given coordinates here ABC are not the vertices of a right angle triangle. So according to the question, they are asking, are these points will be forming a right angle triangle? No. These three given coordinates are not the vertices of a right angle triangle. So we have proved that using the distance formula here. Right. So I hope you guys are familiar with this distance formula by now. So let me know if you have any questions. If not, we can move on to our next one. So any doubts in this question, guys? Quickly. Okay, I hope no doubts. Okay, let's move ahead. So there are few more questions I have given here. So let's make them as homework. So this is one type of question based on the concept of distance formula again. So far we have seen previously two types of questions related to distance formula. Here, one more typical type here, which we can expect question from this concept, distance formula. And the next here, we are jumping into our next concept, which is the section formula. So again, we have learned this section formula in our straight lines. We have even derived their formula for both the internal as well as the external division. Right, so here also the formula will be the same thing, whereas one more coordinate will be added here, which is the z coordinate. So in our 2D geometry, what is the section formula which we have seen? That is mx2 plus nx1 by m plus n comma my2 plus ny1 by m plus n. So this is for internal division. Whereas if it's an external, then it will be a minus instead of plus. Right. So the same formula will be here even for the 3D geometry, whereas the z coordinate will be added here. Right. So if a point P, so in this figure you can see, so if a point P divides the distance, also you can see P divides the line AB here. Right. So in the ratio of m:1, where A is a point having the coordinates x1, y1 and z1. Similarly, B is the point having the coordinates x2, y2 and z2. So now we have to predict the coordinates of the point P. So here this point P is dividing these 2 points in the ratio of m is to n. Right. So then the coordinates of point P are given by, first it will be x coordinate. So it will be m into x2 plus, so it will be always the cross. So m will be here and n will be here. So mx2 plus nx1 by m plus n. So this is the internal division here. And for y, it will be my2 plus ny1 by m plus n. Similarly, z coordinate is added here. So it will be mz2 plus nz1 by m plus n. So these three are the coordinates of the point P, which divides the 2 points A, B in the ratio of m is to 1 internally. Right. So what happens if this m is to n is equal to 1 is to 1? That is nothing but the midpoint of these 2 points. Right. So if the ratio is 1 is to 1, then the point P is nothing but the midpoint of these 2 points, which is given by, so that we can get by directly substituting in place of m and n 1. Right. So that is the midpoint. So which you can identify here. The point P, when the ratio is 1 is to 1, is given to be a midpoint, which are the coordinates are given here as follows. So x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. Right. So if it's the external division, what happens? So this is the formula for internal division. If it's the external division, then the formula will be, then the coordinates will be mx2 minus nx1 by m minus n, comma my2 minus ny1 by m minus n, and then mz2 minus nz1 by m minus n. So this is for the external division and this will be for the internal division. Right. So there is nothing new. The same concept which we have seen in our straight lines. So let's start doing questions here which are related to the section formula. So first question, it's a direct question for both internal as well as the external division here. So quickly solve this and let me know the answer. So here find the coordinates of the point which divides the line segment joining the 2 points, which means let's take these 2 points as A and B with coordinates. So here 1, minus 2 and 3, and here 3, 4 and minus 5. Right, a point is dividing. So let the point be P, dividing in the ratio 2 is to 3. Right, so the first case here which is mentioned, the first condition is the internal division. So apply the formula, section formula which is related to the internal division and find the coordinates of this point P, which is dividing the line segment AB in the ratio 2 is to 3 internally. So what's the formula for internal division? Will be equal to mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n, and then mz2 plus nz1 by m plus n. So here m value is 2 and n value is 3. So it's always be like this. Cross. So So if you have any doubts, you can let me know in the comment section. Those who have done solving it, you can let me know the answer here. And those who have done the internal, you can go by this next part, that is external division for the same ratio and the same points. So just substitute the values here. So m here is 2. So let's do that. So 2 into x2, that is 3, plus 3 into 1. So 2 plus 3, 5 here. Directly you can write that. So 2 into 4 plus 3 into minus 2 and 5 here. And 2 into minus 5 plus 3 into 3 here divided by 5. So let's simplify it. So 6 plus 3 by 5, comma 8 minus 6 by 5, minus 10 plus 9 by 5. So 6 plus 3, 9 by 5 here, and then 2 by 5 here, and minus 1 by 5. So the coordinates of P when it divides internally is given to be 9 by 5, comma 2 by 5, comma minus 1 by 5. So check this, guys, if anyone has already done it. And let me know if you have any doubts in this internal division. Okay, got the answer. So what about the external division? Have you done external division also? If you have done, let me know the answer. For external division, same points and the same ratio. B. Ratio also same here, point B, 2:3. But it's an external division here. So let's do for external division. So m here is 2. So 2 into 3 minus, sign will be changing, right? So 3 into 1. And then here 2 minus 3, comma 2 into 4 minus 3 into minus 2 divided by 2 minus 3. And here again 2 into minus 5 minus 3 into 3 divided by 2 minus 3. So let's simplify it. 6 minus 3 by minus 1. 8 plus 6 by minus 1. Minus 10 minus 9 by minus 1. So 6 minus 3, it will be 3 by minus 1. And 8 plus 6, 14 by minus 1. And here minus 19 by minus 1. That means this will be equal to minus 3, minus 14, and here plus 19. So the coordinates of point P when it's an external division, it is given to be minus 3, minus 14, and 19. And for internal division, we got that to be, so let it be P dash and let the internal will be P. So it is given by 9 by 5, 2 by 5, and then minus 1 by 5. So these are the coordinates of the point P for both internal as well as the external division here. So I hope you guys already got the answer for this. So let's move on to the next question. So here comes the next one. So find the coordinates of the centroid of the triangle whose vertices are given here. So you have to find the coordinates of the centroid. So there is a triangle with the vertices, let it be A, B and C. So A having the coordinates x1, y1 and z1, and B having the coordinates x2, y2 and z2, and C x3, y3 and z3. So now we have to find the coordinates of the centroid of the triangle. So we have already learned what is centroid when we are dealing with the special points of a triangle. So now you can quickly do it. It's nothing but the point of intersections of the median. So if you take a point D here, which is a median, then I have mentioned, so here if it's a BE here and CF here. So if AD, BE and CF are the medians, then the point of intersection here, which is the centroid G, right? And this centroid will be dividing this line segment AD in the ratio of 2:1. So this is the concept. So now we have to apply this in order to find the coordinates of the centroid of the triangle. So first find the coordinates of point D, which is the midpoint here. And then by applying this section formula concept, you can find the coordinates of this centroid G. So here now the line segment will be this A and D here, which is the midpoint, and A is having the coordinates x1, y1 and z1, right? And we know the centroid will be here, which divides this line segment in the ratio of 2:1. So the first thing, in order to find the centroid of this triangle, we have to figure out the coordinates of this point D, which is the midpoint of the line BC. So first find the coordinates of D here. Quickly find the coordinates of D, guys, first. It's the midpoint. If anyone has already done it, you can let me know that. So D is nothing but the midpoint, as I mentioned. So midpoint, in the sense, it's in the ratio of 1:1. So we have just seen for midpoint what will be the coordinates, simply the average. That means x2 plus x3 by 2 and y2 plus y3 by 2 and then z2 plus z3 by 2. So now this is a line segment AD, and this point G, which is the centroid, divides this line segment AD in the ratio of 2:1. Right, so now apply the section formula. So 2 will be here and 1 will be here. So now G will be having the coordinates 2 into x2 plus x3 by 2 plus 1 into x1 divided by 2 plus 1, it will be 3. And then 2 into y2 plus y3 by 2 plus here 1 into y1, so y1 divided by 2 plus 1, 3. And next for z, 2 into z2 plus z3 by 2 plus z1 divided by 2 plus 1, 3. Right, so now here this 2 will be getting cancelled in each of the coordinate, and we'll be remaining with, in the numerator it will be sum of all the 3 coordinates, that is x1 plus x2 plus x3, and in the denominator it is 3. So now the coordinates of the centroid G is given to be x1 plus x2 plus x3 by 3, comma, here same with the y coordinates also, y1 plus y2 plus y3 by 3, and z1 plus z2 plus z3 by 3. So these are the coordinates of the centroid of the triangle, whose vertices are given here by x1 comma y1 comma z1, x2 comma y2 comma z2, and x3 comma y3 comma z3. Right, so this is the final answer here. So we'll just wind up our session. So we are done with the distance formula and section formula. As I mentioned, the rest of the topics of this 3D geometry that you are going to learn in your 12th standard, along with the chapter of 3D geometry as well as the vector algebra. Right, so let me give you a question for homework in the section formula, in the concept of section formula. So take this question as homework and work it on. So this is one type of question you can expect from this concept of section formula. Right, so in our today's session, we have just started with the introduction part of 3D geometry, the representation and writing the coordinates of a point and the signs in each of the 8 octants. And then we have seen our distance as well as the section formula. And we have done few models of questions related to the distance as well as the section formula. Right, so I hope you guys are understood our today's session of 3D geometry, and we are having few more concepts in 3D geometry that you are going to learn in your 12th standard. So that's all for today. So we are done with this chapter of 3D geometry, and in our next session we are going to start a new chapter, a new topic. So that's all for today. So if you have any questions, any queries, you can let me know. So that's all for today, guys. We'll just start a new topic in our next session.